Okay guys, so chapter 8 closure. Question 1 says you have a 12gon. Okay, so again, I drew 12 equal triangles going to the center and a circle that's inside it. In order for us to find the area of the shaded region, we have to find the area of the 12gon right here and subtract the area of the circle. Okay, so I took a look at this and I was like, well, can I find the area of the 12gon? Not easily. Can I find the area of the circle? I sure can. The area of a circle is pi radius squared. I would pause the video and write that on your cheat sheet. The circumference of a circle is pi times diameter. We do not need that for this problem, but you may need that. Again, this is for the crust. That's the perimeter, and the area is the shaded in the whole area of the circle, okay? In this part, we're using the area of the circle. So they told me that the radius, if you read the question, the radius of the circle is 2. So I went ahead and filled in pi 2 squared, and I'm just going to go ahead and do that. So use your pi button times 2 squared, and I'm getting 12.57. That's the area of the circle. So that represents the area of this, all shaded in right here. But what we need to find is we need to find the area of this 12gon and subtract the area of that circle. So to do that, if you guys notice, I pulled out one of the triangles right here, okay? And they told me that the side is 8. Now I do have 12 of these. That's why eventually I'm going to be multiplying the area of that one triangle by 12. So to find the area of this triangle, it is 1/2 times the base, which is 8, times the height, which we do not have. So I'm going to drop that right there, and that's going to be my height. I will call this x because I need that. I don't know what it is. So in order to do that, we are going to figure out how big the central angle is first, right here. So I'm going to start by doing 360 divided by 12, and that gives me 30 degrees. And what that does is it tells me that one of these angles up here is 30 degrees. Now, when I dropped that little dotted line, if you remember, it cut that 30 degrees in half. So this side is 15 and this side is 15. And then it also split the 8 up to 4 and 4. And so what we're going to be doing is we're going to be using half of this triangle right here, and we're going to be using trig. And so the trig with this triangle right here, we're going to be using the side opposite, and the side we are looking for is the adjacent side. So opposite and adjacent is tangent, so the tangent of 15 is equal to opposite 4 over adjacent x. Put this over 1 and then go ahead and cross multiply. So 4 times 1 is 4. I almost wrote down 4 times 1, but 4 times 1 is 4. And x times the tangent of 15, and then divide by the tangent of 15 to get x. So x is equal to, in my calculator, I'm going to do 4 divided by the tangent of 15, and I'm getting 14.93. And again, that tells me the height. So when I go to find the area, I can now erase the h and replace it with 14.93. Okay, so the area is going to be 1/2 times 8 times 14.93. So the area of this triangle is 59.72. But keep in mind there are 12 of these triangles. So you're going to multiply that by 12 and get a total area of 716.64. Okay, so that total area is going to be 716.64. And again, that area represents the 12gon, okay? And we're subtracting the area of the circle, okay? So your overall area of the shaded regions should be 700 and about 11. So let's actually type this in though. 716.64 minus 12.57, which represents the area of the circle, and I'm getting 704.07. Did I say 711? Because I'm crazy. Okay, so this is the final answer right here. That is the area of the shaded region. Again, you had to find the area of the 12gon. So 360 divided by 12 gave us that 30 degree angle. We split it in half. We also split that base of 8 in half, and then we used trig to find the height. Okay, the height ended up being about 14.9. So the area of the triangle is 1/2 the base times the height. And again, there were 12 of those triangles. Okay, and then the area of a circle is pi r squared. Number 2. So number 2 asked us to graph these. You guys can see that I already graphed these. I also wrote some things over on the side. And again, I would pause and make sure these quadrilaterals are drawn on your cheat sheet. So the first one is a kite. You have to remember that a kite has the top 2 segments are congruent, the bottom 2 segments are congruent to each other. Also, the diagonals are perpendicular. In other words, they form 90-degree angles. Okay, to prove that, the slopes are going to have to be opposite reciprocals. So if you want to prove something is a kite, that's what you're going to look for. Then we have a parallelogram. Okay, so the top and the bottom are parallel, the left and the right are parallel. And to prove something is parallel, the slopes have to be exactly the same. The slope triangles have to be the same. Now a rhombus is a parallelogram. That's why there's an angle drawn up here. A rhombus is just more specific because it has 4 congruent sides. So to prove something's a rhombus, you want to first look and see if it's a parallelogram. And then if it's a parallelogram, you then have to check to see if the sides are congruent to each other. In other words, they have the same length. So when we worked with these quadrilaterals, we worked with slope, which tells you if it's parallel or perpendicular. And then we also used distance to prove that the sides are equal. In other words, the length, okay? Then we have our trapezoid over here, and a trapezoid has 1 pair of parallel sides, okay, 1 pair of parallel sides. And the last one is our rectangle. And again, the rectangle is a parallelogram. It's just a more specific one. What's so special about a rectangle is the diagonals are congruent to each other, so they do have equal diagonals. Those diagonals get bisected because it is a parallelogram, so keep that in mind. I don't know why I drew different tick marks. They should all have the same tick mark. Okay, so a rectangle, again, has congruent diagonals. The diagonals got bisected because it's a parallelogram. Opposite sides are parallel. And then also what's special about a rectangle is it has 4 right angles. Now, again, if we're talking right angles, we are going over to slope and we're talking perpendicular. Okay, so the first question on here asks me, what is the most descriptive name for this, and justify. Looking at this, it appears to me that it's going to be a rhombus. So to prove it's a rhombus, I first want to show that it's a parallelogram. Okay, so I want to show that it's a parallelogram. And to do that, the sides have to be parallel. So we can see that AD is parallel to BC. And that is because they both have that undefined slope. The next thing I'm actually going to do is I'm going to draw a little triangle right here to take a look. I'm going to shade it in with this. Okay, so I'm going to look at this red triangle in relationship to this blue triangle right here. And that helps me. Those are my slope triangles. And so the blue one looks like it goes down 3/4. The red one also appears to go down 3/4. And what that is telling me is it's telling me that these purple sides, DC and AB, DC has to be parallel to AB. And so what's so special about this now is that this made it a parallelogram. So I know it's at least a parallelogram. I want to check to see if it's a rhombus. Now, to see if it is specifically a rhombus, I need to make sure that the sides are all the same length. Okay, so I need to check the side lengths. It's really easy to find the side length for AD. I can just count because it's straight up and down. So it goes 1, 2, 3, 4, 5. And same thing for BC. I can see that it goes up 1, 2, 3, 4, 5. I also need to find the length of AB. To do that, I'm going to use that red triangle, and I'm going to use Pythagorean's theorem. So I would do 3 squared plus 4 squared is equal to the hypotenuse squared. And if you go through and do this, this is actually just a 3, 4, 5. Okay, so this is my AB, my red triangle. I pulled out my red triangle, and we can see that AB has a length of 5. I would do the same for my blue triangle with DC. So here's D and C, and you can see this triangle right here has sides that are 3, 4, and this obviously then is going to have a length of 5. So because all the sides are the same length, and I proved it to you, I'm going to say that the final name for this is a rhombus. And I'm going to highlight this. This is my final answer right here. It is called a rhombus. To find the area of a rhombus, okay, the area is just base times height. And what I'm going to use for the base personally is going to be AD. So you guys can see AD. I'm going to come up here and erase this because this is getting to be a lot of stuff. So let's erase this. So again, I'm going to use this AD as my base. And then the height is just the perpendicular height off of that. So we can see that AD has a length of 5. I already stated that. And the height is 1, 2, 3, 4 squares, making the area of this 20 units squared. Find the slope of the diagonals from A to C. So again, I'm going to come up here and erase this. Find the slope of the diagonals from A to C and B to D, and how are the slopes related? Okay, so let's go ahead and look at this. From A to C, they want to know what this slope is. So I like to build my slope triangle. Boop, 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 boop. There's my slope triangle. And it looks like it goes down 1, 2, 3, 4, 5, 6, 7, 8. So down 8 over 1, 2, 3, 4. Okay, and we always want to reduce this. So this reduces to down 2 over 1. That's the most reduced slope. And then they also wanted me to find the slope from B to D. And it looks like that slope triangle goes up 2 over 4, which reduces to 1/2. So let's go ahead and write that down here. So AC was down 2 over 1, and BD was up 1 over 2. And how are those slopes related? Because they are opposite reciprocals, they are perpendicular. Okay, so that means that, again, the diagonals are perpendicular. Okay, just like in a kite, in a rhombus, because a rhombus technically is a kite, those diagonals are perpendicular. Let's take a look at this. So they want us to prove that KL is equal to QP. So let's see what they're telling me. The first piece of information that they're telling me is that M is the midpoint of KQ. And so I'm going to write that down. M is the midpoint of KQ. And I know that because it's given to me. What I can draw out from that is that KM is then equal to MQ. And the reason I know that is because of the definition of midpoint. You can also explain that, if a point is a midpoint, then it is cuts that segment into 2 equal segments, then it's right in the middle. However, you can kind of describe that, but that's just the definition of midpoint. More given information right here. They're telling me that angle P is equal to angle L. So this is this angle right here, equal to this angle. So that, again, is given to me. Angle P is equal or congruent to angle L, and that is given. And so I have a lot of information here. I have a side and a side already. I have this blue angle with this blue angle. And if you guys remember, I don't have parallel lines, so don't do the Zorro, the little Z angles. But I do have vertical angles. So I have angle, I can't say M is equal to M, so I'm going to name it with 3 letters. Remember, KML is equal to angle, I used K, so I'm going to do Q. QMP. M has to be in the middle, that's your vertex, and that is because those are vertical. Vertical angles are always equal to each other. And what we have now is we have 3 pieces of information. I have this angle, and that side. So I can officially say triangle, the whole triangle KML is equal to the whole triangle QMP, and that is by angle, angle, side. You can see that above. And once the triangles are equal, then that little side of KL has to equal that little side of QP, because if the triangles are congruent, then their corresponding parts also have to be equal. Okay? Everything about that triangle has to be equal to that triangle. Next one, let's take a look at A. So I see that this triangle is isosceles, which means if I folded it in half, this angle lands on top of that angle. Therefore, 4x plus 9 has to equal 5x plus 5. Okay, subtract 4x from both sides. I'm also going to subtract 5. So I have 4 is equal to x. Okay, so it says use the relationship in the diagram to find the value of the variables. The diagrams are not drawn to scale, so keep that in mind. Next piece of information for B, it says find the variables if possible. So originally I was like, wait a minute, so if this is 2y, I can move it over, and this is going to be 2y, and I add those up and set it equal to 180. The problem is I don't know if these are parallel. If they were parallel, I could move this over here, and I can say this is 2y, this is 2y, but it does not tell me that these are parallel, so for now I'm going to put not possible. Okay, I'm not really sure. And then my last section right here, I'm going to start with this 117. I would do 180 minus 117 to get that 63-degree angle. And then we know that these three angles added together have to equal 180. Okay, so 40 plus 63 plus z has to equal 180. And then go through and solve, and you should get z is equal to 77 degrees. The next question, if there's not enough information or it is impossible, explain why. Find the sum of the interior angles of a dodecagon. So I would pause this and write sum of the interior angles is n minus 2 times 180. N is the number of sides. I would pause this and put this on your cheat sheet, okay? So what is the sum of the interiors of a dodecagon? A dodecagon is a 12gon, okay? If you didn't remember that name, that's okay. And so what you're going to do is the sum of the interior angles is going to be 12 minus 2. That means there are 10 triangles times 180. And so the sum of those angles is going to have to be 1,800 degrees. Okay? Find the number of sides of a regular polygon if its central angle measures 35. So keep in mind that those central angles get placed together, okay? And we need to basically figure out how many central angles there are. If one of them is 35, 35, 35, 35, they're asking us how many of those you need. Will go into 360. So central angles always are going to add up to 360. And again, if that's something you want to put in your cheat sheet, those central angles always are going to add up to 360. So they're asking me how many of them, how many 35-degree angles will we need? So I would do 360 divided by 35. And let's go ahead and do that. 360. Quit. Of course, my calculator is not working right now. 360 divided by 35. And it tells me I would need 10.29 sides. And there is no such shape. You have to have a whole number of sides, like 4 sides, or 5 sides, or 6 sides. You cannot have 0.29 of a side. It does not make sense. So this one cannot be done, okay? The next one, if the sum of the interior angles is 900, so immediately I'm writing down sum of the interiors is n minus 2 times 180. They're telling me that the sum of the interiors has to be 900. 900 has to equal n minus 2 times 180. Now, this is up to you. If you want to plug in numbers for n and see what makes this true, go ahead and do that. I'm just going to solve this equation by distributing. So I'm going to distribute this 180. 900 is equal to 180n minus 360. Add 360 to both sides. Okay, and I'm left with 1260 is equal to 180n. 1260 divided by 180 is equal to 7. So n has to be 7. There are 7 sides. If the exterior angle of a regular polygon is 15, okay, find its central angle. So the first thing is we need to remember that exterior angles, the sum of exterior angles is 360. So if one of them is 15, what we're going to do is we're going to figure out how many exterior angles there are. So if I take the sum of the exterior angles and divide it by 15, so 360 divided by 15, I'm getting that there are 24 exterior angles, which means there are 24 sides. It says to find its central angle. So again, if I do 360 divided by 24, because there are 24 central angles, that is also going to give me 15 degrees. Okay, so the exterior angle and the central angle end up being the same. Hint, hint. Find the measure of an exterior angle of a regular polygon with 10 sides. So if there are 10 sides, there are going to be 10 exterior equal angles. And that is because it is a regular polygon. So again, the sum of the exterior angles is always 360. If there are 10 of them, that means each of them are going to have to be 36 degrees. Okay. So find the measure of each of the angles below if possible. If it is not possible, explain not possible. If it is possible, state your reason. Okay, so find the measure of angle B. So I'm taking a look, I see that I have some parallel lines, so I can immediately take this 101, slide it over, and say B is 101. E is also 101, F is 79, and A is 79. C is 79, G is 101, and H is 79, sorry. So we have some of our missing angles right there, okay? Let's take a look up here. Now these are the only angles right now that I'm capable of kind of maneuvering. I cannot take this 101 and slide it down right here because these two lines are not parallel. So I can't do that. So come up here and answer the question. B is 101. M, I cannot determine. H is 79. F is 79. G is 101. And I cannot determine at this time. Okay? So now they're going to give me more information. They're going to tell me that the measure of angle P is 130 degrees. So P is 130 degrees. Can you find the measure of any of the angles from part A? Yes. Once we know that this is 130, and I'm given all of these parallel lines, so I can take this 130 and I can use vertical angles. I can also slide it over to N and say 130, and then I can slide it down to V and say 130, and I can slide it over here and say 130. So that's going to help me figure out some information. It also tells me that M is 50, and that's going to help me find the measure of angle I because of this triangle right here. So 180 minus angle H and angle M together, which is 129. And so that's going to give me 51 degrees for angle I. Okay, so 51. And then angle M, I have down as 50. Okay. So find the area of the sector. Again, I would pause. I would say area of a circle is going to be pi radius squared. So the area of this entire circle is going to be pi 6 squared. And let's go ahead and type that in. Pi times 6 squared equals 113.10. I'll say yards squared. Okay, that's the entire circle. That's not the right answer yet. It wants only 45-degree piece. How many 45-degree pieces in a circle? There are 8 equal pieces. So what I have to do with this area is I then have to take the 113.10 and divide it by 8. So the area of that one sector, 113.10 divided by 8, the area of that is giving me 14.14 yards squared. Okay. Now it said to find the length of the crust. I have to find the whole circumference, which is pi times diameter. In this case, it's pi times 12. Okay, keep in mind the diameter goes all the way across. So in my calculator, I'm coming over here, pi times 12 is giving me 37.7. That's the entire circumference though. Remember, mine's only cut into 8 equal pieces. So I divide that by 8, 37.7 divided by 8 equal pieces, and I'm getting 4.71 yards. For 9, it asks to solve this equation. You should start by distributing this -1, distribute the -6. Next thing, you should always combine like terms that are on the same side of the equation. Okay, so these are on the same side of the equation. -1 plus 42 is a positive 41. -7x and a positive 6 is a -1x. Now you can start moving things, so I would subtract 41 and divide by -1. And the last problem right here, a mid-segment. When you draw a mid-segment, you're cutting essentially the triangle in half. Okay, so if this big side down here is 36 and it gets shrunk, then y is going to have to be 36 divided by 2, which ends up being 18. To use this, you know that there has to be 2 of these, 2x plus 4s to equal the 4x minus 2. So 2 of the mid-segments, 2 18s is going to give you 36. 2x plus 4s is going to give you 4x minus 2. Go ahead and go through and distribute. Okay, and then subtract. So 8 is equal to 2x minus 2, add 2. 10 is equal to 2x, and divide by 2 for your final answer. Okay, now, things that I would add to your cheat sheet. So here is a list of things I would add to your cheat sheet. Mid-segment. That is what we just went over. When you connect the midpoints in a triangle, every single time it's going to be half as big. So if this is 4, this is 8. I would make sure you have mid-segment on there. Make sure you have all your parallel line stuff, especially your Zorro angles. When you see parallel lines anywhere, okay, you can always trace those parallel lines like this. There's my blue parallel line, there's my blue parallel line, okay, here's my parallel lines. And these alternate interior angles are always going to be the same. So make sure you guys know your parallel information. Make sure, go back to that slide with the quad. I think it was slide 3. Make sure you guys have your quads down. Make sure you understand what slope tells you. Make sure you know what a rectangle is, a trapezoid, a rhombus, a parallelogram, and a kite. So I would pause it right here, and I would copy down these diagrams of some quadrilaterals. So let's see. So again, I would have those quads drawn. I would make sure on slide 2 that you know how to find the area of a regular polygon. And so keep in mind, I don't know, hexagon, octagon, whatever it is. Keep in mind that you always want to draw your triangles. So with this one, I have 6 triangles. You find your central angle. So 360 divided by 6, whatever, 60 degrees. Then you take that and you cut it in half, and you use half of this triangle right here. Okay, so this one I would take that 60-degree angle and cut it in half to get 30, and then cut the base in half as well, and then find the area of one triangle, find the area, 1/2 times base times height, and multiply it by however many there are. So make sure you guys can find the area of a regular polygon that way. Make sure you know that the area of a circle is pi r squared. The circumference of a circle, or the crust, is pi times diameter. Maybe draw a little picture with this is the radius. Draw a picture with this is the diameter, so you remember that. Make sure you know that the sum of the interior angles is the number of sides minus 2 times 180. The sum of the exterior angles is always going to be 360. If you ever want to find one interior angle in a regular polygon, once you have the sum, you can just divide by however many there are. Same thing with the exterior angles in a regular polygon. If you just take 360 and divide it by however many sides there are. And then keep in mind that an interior angle plus one exterior angle will always equal 180 degrees. So whatever your shape is, this is my interior angle. If I draw this out, this is my exterior angle. Those will always equal your windshield wiper, 180 degrees. And I think that's it. So just some things, again, that I would add to my cheat sheet.